Hi everyone, welcome back. So we're going to continue looking at the sun, the earth, and the moon. We're going to focus a little bit on motion though today. Before we begin, I want to remind you that if you need to contact me, please use my email. Google Classroom is not as effective. You can see my email is posted there, rcrawford@jcpsmail.org. I will get back to you on Google Classroom, but email is always the fastest. The second thing I want to remind you is if you ever have trouble with one of my videos, you should hit refresh. You may need to do it several times. It's not a problem with the video. It's just probably your browser. So, without further ado, let's get into today's lesson. So last week we talked a little bit about size, and I want to talk about motion. These are three terms that you have absolutely heard before. The terms we're going to be looking at, and they're all sort of closely related, are rotation, revolution, and orbit. And we're going to use this image here to see if we can make certain we understand what those are. Let's begin with rotation. So if we begin with a rotation, it says rotation is a type of motion where an object spins on its imaginary axis. So when we think about things spinning on an axis, what we're talking about is we can almost imagine them staying in place. And I want you to look at these arrows that are here on these objects themselves. So I want you to pretend that this is like a wheel on an axle, and they are just turning over and over without really moving through space, but they're able to spin or rotate on an axis. The Earth has rotation, and also the Moon has rotation. Our Sun, though it's not shown here, also has rotation. Rotation is one type of motion, and I want you to imagine that we are talking about something like a wheel spinning on an axis. The second type of motion that we want to talk about is revolution. Revolution is a type of motion where the object travels around another object. So when we look in our solar system, if we have that immense star, our sun, in the center of the solar system, our sun has an incredible amount of gravity because it's so huge. This drawing is not to scale. If you remember the picture that we looked at last time, our sun is much, much bigger than it's shown here. But to make everything fit, we have chosen this image. And so here it is in the center. And we can see this line that we have going around. And as an object goes around another object, we call that a revolution. Okay? So a rotation means something spinning on an axis. A revolution is one object traveling around another. So the Earth revolves around the sun. If we look, though, we have our moon, which is revolving around the Earth, which is revolving around the sun. So a revolution is a type of motion where one object travels around another. This word here, orbit, this turns out to be a little confusing in my opinion. So an orbit is the actual curved path of an object around another object. It is very closely related to revolution. So for me to show you what an orbit is, I want you to just look back at the diagram, and I want you to look and see this is the path. So every time Earth goes around the sun, it's going to take this path. So we just call this path that it takes the orbit. It's the actual physical location. So it's not the type of motion like revolution. It is the actual physical path that something takes. So rotation, spinning on an axis; revolution, one object traveling around another; and an orbit is a physical path, but very closely related to revolution. As a matter of fact, I've seen many people use orbit and revolution. It sort of as interchangeable terms, meaning they'll sometimes use one when they should probably be using the other. I may be guilty of that at times myself. See if you can catch me. So we have these two types of motion, and we've set out these physical paths. So let's think. So now that we have these terms, I want you to actually pause the video when I say go, and I want you to think about an answer to these questions. These are things that some of you are most likely going to know. Question one is, how long does it take Earth to travel around the sun one time? So how long does it take Earth to travel along its orbit, that physical path, one time? To make one revolution, if you will. Or the second question, how long does it take Earth to rotate on its axis once? So how long does it take Earth to rotate just one time? So I want you to go ahead and click pause. Once you have your answers, start the video again. All right, welcome back. So as we look, let's look at our revolution. Okay, so the question was, how long does it take Earth to go around the sun one time? And some of you, I think, probably got the answer that that's 1 year or 365 days. Now, some of you may know it's a tiny bit longer than 365 days. It's 365 and 1/4 day, and that's why we have leap year. But that's a little bit beyond this discussion. So the Earth makes one complete revolution around the sun every 365 days, which is 1 year. I want to go ahead and point out at this point that we talked about the Earth we talked about the moon revolving about around the Earth, and so most of us don't know what that amount of time is, but it turns out to be about a month. So 27.3 days to be exact is how long it takes the moon to revolve one time around the sun. So did you get it right? While we're talking about revolutions, I want to go ahead and let's take a look at Earth's orbit. This is something that many students are slightly confused by, and it's not your fault. To be frank with you, the reason that many of you have an idea of the wrong shape is because you've looked at diagrams that are trying to help you. So let me just say this. The shape of Earth's orbit is going to be mostly a circle. Okay, so the shape of Earth's orbit is going to be a circle. Now, some of you have heard that it's elliptical or it's kind of oval shaped or a squash circle. Well, that's kind of true, but it's only slightly elliptical or oval shaped. As a matter of fact, if you were to draw it, you wouldn't be able to see it. So if you were to draw it, you would look at it and think, oh, that's a circle. And that's what I've done here. So the shape of Earth's orbit is mostly a circle. Although it isn't a perfect circle, it is mostly a circle. I think some of you have seen diagrams that look more like this one here over on the right-hand side of the screen, that this orbit B, that shows it being much, much more elliptical or oval shaped than it really is. So as we move along, I want you to keep in mind that this is not accurate. This is not a good way for you to think about the shape of Earth's orbit. On the other hand, orbit A, that's fairly accurate. Is it perfect? No. But is it mostly a circle? Yes. Let's take a look at rotation. Remember, one of the questions that I asked you to think about was, how long does it take Earth to make one rotation on its axis? Most of you probably guessed that's 1 day. So yeah, 1 day or 24 hours is how long it takes Earth to make one rotation. Let's take a moment to look at our image here. So we have to imagine that here on this side of the screen over to the right, we have the sun. How do I know the sun would be over there? Well, because look, here we have the side of the Earth that is facing toward the sun. It's daytime. It's getting plenty of light and warmth from the sun. On the side that's facing away, it's going to be that half that's facing away, it's going to be night over there. So the side facing toward the sun, it's going to experience daylight. The side that's facing away from the sun is going to experience nighttime. And we can see that we have those changing periods of day and night. So as the Earth rotates on its axis, we're going to have it become day and night in different places. And this place right here, right where we see this line between light and dark, this is going to be a sunrise right here. So the sun is just going to be rising right here. And as Earth continues to rotate, a sunrise keeps happening elsewhere. So Earth rotates on its axis about every day or 24 hours. And this is responsible for those periods of day and night that we have on our planet. I do want to point out that it's not just Earth that experiences day and night and that is half lit and half dark at all times. That is every object in our solar system. So normally, every object is half lit or experiencing day and half dark or experiencing night. But while we're thinking about rotation, I want us to take a moment and notice the moon also rotates on its axis, and most of us don't know it, but it takes 27.3 days. That's interesting. Also about 1 month. So if we think back, if we look, we said that the moon's revolution, it takes the moon exactly 27.3 days to make one complete revolution, to travel around the Earth one time. Interestingly, it also takes the moon 27.3 days to rotate once on its axis. That's going to turn out to be important for us later. So please don't forget that. The Earth's rotation and its revolution around the Earth are exactly the same. Oh, so we have another place where we can stop and think. When I say go, I want you to pause the video. So here's my question for you. What are some things that orbit around the Earth? Now, clearly, some of you are going to think, he just talked about the moon. So the moon is one. Can you think of anything else? Once you have your answer, I want you to hit play on the video again. And go ahead and pause. And welcome back. So hopefully most of you were able to think of some things that are really helpful for us in our everyday life. Maybe some of you have TV, receive a TV signal from a satellite. Many of you use GPS, meaning Global Positioning System. That also comes from a satellite. Many of us like to know how the weather is going to be in the next day or in the next week. We have satellites in space that are man-made or artificial satellites that give us that information. So we have the moon, which is what we call a natural satellite. And then we have things that you might think of when you see the word satellite that are also orbiting around the Earth. Now, in addition to these things, we have other artificial satellites called space junk, which is just debris. It's man-made debris that is orbiting around our planet. And if we get some time, maybe we can talk about that later. For now, a satellite, I want you to just think about it as any object that orbits around another larger object. So satellite, most of us think this, but satellite can also be this. So we have two types of satellites. We have two types of satellites. And please don't forget those natural satellites like our moon when we start thinking about the word satellite. So back to our moon. Most of you have taken some time, I hope, to go outside and to look at the moon. And when we look at the moon, we're going to spot really three different types of places. So if we look at this picture of the moon, we can see that we have these dark places here. Okay, so we have these really dark places on the moon, and they just look rather smooth. A long time ago, before we really understood, people thought that those were bodies of water. They thought they were seas, like an ocean, that were on the moon. And when you look at this image and when you think about what you can see, that's not a terrible answer. So we looked at the moon and thought, wow, there's water there. And so they thought these were called seas. So we also have some other places here that are much lighter in color. So if we can see these lighter color places. And then we have like these really bright spots. So here's a bright spot, and we can see these bright spots that are all over the moon as well. And some of these bright spots have these streaks that are leaving them that seem to radiate out from them in every direction. This one right here is a great example. So we have these basic surface features that we can look at the moon and we can easily see. So let's talk a little bit about those dark colored areas on the moon. So these dark colored areas on the moon, those are called Maria. And so Maria are dark places, and really they are just these smooth, flat plains. So not mountainous, they're plains, and they're very relatively smooth and flat. Uh, these are actually lava flows, and I'm going to say that they're very old, but they're not as old as some of the other places on the moon. So we have these are not fresh lava flows. This is actually just lava rock. And these Maria, these are these dark colored places. These are old lava flows. So let's take a look at these lighter colored areas. These lighter colored areas are much, much older. These lighter colored areas are called highlands. And I want you to think of these as being sort of rough mountainous or hilly areas. And really, when we take a look at it, there is more of the highlands than there are of the Maria, right? So there's more of these mountainous areas than there are of these flat plains that are old lava flows. The third feature that we want to take a look at, the third surface feature, is going to be craters. Now, craters are these are actually bowl-shaped, I'm going to call them dents or depressions that are caused by impacts. And by impact, I mean something ramming into the moon, like a big piece of space rock. You know, it comes in and it may be traveling thousands of miles per hour. And when it hits the moon, it is going to leave a big dent behind. And so we call these craters. And the moon is pretty heavily cratered. We can see craters almost everywhere of different sizes. And of course, The bigger the piece of space rock that hits the moon is, the bigger the crater it's going to leave behind. Some of these bright streaks that are leaving these craters are called rays. These rays are caused or created during the impact. Sometimes this material is ejected or gets exploded out of the moon, and it goes racing across the surface of the moon. And so this material called ejecta that comes out of these forming craters, they leave behind these rays. So our main surface features are maria, the dark colored areas, which are lava flows, smooth flat plains; highlands, the lighter colored areas, which are mountainous areas; and then we have all these craters that were made, these dents that were made by space rocks hitting the moon. If you haven't really paid attention, I want you to go outside and take a look at those. So we always see the same side of the moon, and this is a little bit strange because some of you have heard about the dark side of the moon. I do want to point out that there is no such thing as the dark side of a moon. The dark side of the moon is kind of a myth. It's also an album by a relatively famous rock band, but all parts of the moon are going to receive sunlight, so there is no dark side. What a better way to think about it is there is something that we might call the far side of the moon. So the far side of the moon is the side of the moon that we never see. You would have to travel into space on a spacecraft and go orbit around the moon to to see this side of the moon. And this is because the same side of the moon always faces toward the Earth. Now, that's a little strange because hopefully you're saying, well, wait, Mr. Crawford, didn't you tell me that the moon is actually rotating on its axis? It takes 27.3 days for it to make one complete rotation. Well, you're right, student, I did. But here's the problem. Its rotation and its time for one complete revolution are exactly the same. And because its rotation, 27.3 days, is exactly the same time as one revolution, 27.3 days, it has the effect of the same side of the moon being always facing toward the Earth. And so we never see this side of the moon. We do call this the far side of the moon. One thing that you may notice is because the far side of the moon is always pointed out away from Earth and it's always pointed out into space. I want you to notice that it has had many more impacts. It is much more heavily cratered. So lots of space rocks have ran into this side of the moon. And the far side of the moon looks much different than this near side of the side of the moon that we're used to seeing. Okay, stop and think. I want you to pause the video. So we looked a little bit when you were looking at your moon bases and doing that research about what the conditions are like on the moon. So I want you to think, could you survive on the moon if you crash landed there? Does the moon have everything that you need for survival? I want you to think about that. Once you think you have an answer, I want you to go ahead and start the video again. Go ahead and pause. Welcome back. So, what's it like on the surface of the moon? Please notice in the picture that we have an astronaut here who is trying to survive. Notice that they're wearing a spacesuit. Why is that astronaut wearing a spacesuit? Well, frankly, there's no air. Unlike Earth, where we have this unlimited supply of air, we have an atmosphere that surrounds us at all times. There is no air on the moon. So the moon has no atmosphere. Doesn't have a breathable atmosphere. You would suffocate. You would die almost immediately if you were dropped off on the surface of the moon with no spacesuit. Now, as you look around, you can see that this is from a moon landing, and they are in one of those maria. So I said that it was a flat plane. You can see that it's really flat here in this maria. And if you look, you see that there's nothing but really this gray dust and a few rocks that cover the surface. So there's no liquid water. There are no plants. There are no other living things that we've been able to find yet. So the moon is really inhospitable, meaning that it's very harsh and very rough. It is not a good place to crash land. Survival would be impossible without you having supplies or being resupplied. So no air, no liquid water, and no life. And the other thing that spacesuit is protecting this astronaut from is the extreme temperature changes. So the side of the moon that is facing toward the Earth is going to experience some very high temperatures, 260 degrees Fahrenheit. So 260 degrees when it's daytime, but then you would eventually find yourself over the course of a month, 27.3 days, you would find yourself facing away from the sun and it would be nighttime. For roughly for 13 days, the temperature would be minus 280 degrees Fahrenheit. That is incredible. Some of the coldest temperatures on Earth, which are down near Antarctica, down near the South Pole, are minus 100, minus 280 degrees Fahrenheit. You would be frozen. So the surface conditions on the moon are terrible. It is not hospitable for life. No bueno. The last thing we're going to talk about today is moonlight. I believe that most of you at this point know that the moon does not produce its own light. The moon is really just a rock. It is a rock with no life on it, and that's orbiting around the Earth. So if the moon doesn't produce its own light, how do we see moonlight? Clearly, when you go outside at night and you look up, there is light coming from the moon. Well, moonlight is simply sunlight that is reflected off of the moon's surface. So if we look, and we can see here that we have light from the sun, and part of it makes it to Earth, and so we can see that if you're here on Earth, it's daytime. But part of that light is also going to the moon, and it's bouncing off the moon, it's reflecting, and it's bouncing back down toward the Earth. Okay, so moonlight is simply sunlight reflected from the moon's surface. Okay, all right, last thing we're going to do today, very simple assignment for you. In your science notebook, I want you to write some definitions for these key vocabulary terms. Remember, you are likely going to see these very soon on some sort of quiz. So the words that I want you to look for definitions for in the video, and you'll need to rewind and pause. I want you to look for definitions for rotation, revolution, orbit, Maria, and highlands. Okay, guys, that's really it for the week. So, and excuse me, for the day. And so until next time, stay curious.